nice question, question 4. F of x is x squared plus 2x. Solve f of x plus f of x plus 1 is 23. Now f of x is just f of x. Nothing needs to change there. We need an expression for f of x plus 1. Now what that means is wherever you see x, you're going to replace it with x plus 1. So f of x plus 1 here will be, remember to use a bracket, x plus 1 squared plus 2 bracket x plus 1. Now we just need to expand everything. So x plus 1, x plus 1. Here we can expand this one, 2x plus 2. So we have x squared plus x times 1 is x, plus another x, so that'll be 2x. Then we have the 1 times 1 is just 1. Then we have that plus 2x plus 2. Simplifying, we have x squared. We have 2x plus 2x is 4x. Then we have 1 plus 2 is 3. So what we're actually solving is f of x, which is x squared plus 2x, plus f of x plus 1, which we just worked out to be x squared plus 4x plus 3 equals 23. Simplify, x squared plus x squared is 2x squared, 2x plus 4x is 6x, then we have that plus 3. I think we're going to move everything to one side first. So the 23, we move it over to this side. It would be subtracting 23 on the left side. So 3 minus 23 is minus 20. We can divide every single term by 2 first before we solve. Dividing by 2, we get x squared plus 3x, then minus 10 is 0. Now we can factorize and solve. So we've got x and x, 10 is 5 and 2. To make plus 3, we need plus 5 and minus 2. So either x plus 5 equals 0, which means x equals minus 5, or x minus 2 equals 0, which means x equals 2 when we rearrange. And those are our solutions for question 4. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Question 7, we have f of x equals 3x minus 2 and g of x is 2x plus 1. Find f gx. So f of g of x. So it means we're substituting in g of x into f. So when we observe the function f, wherever we see x, we are going to change it to g of x. So it becomes 3. And then instead of x, remember we're changing it to g of x minus 2. So we have 3. Now g of x is 2x plus 1. We need to use a bracket. And then we subtract 2. Yeah, just carrying over. So we have 6x plus 3. Then we have the minus 2. So our final answer here is 6x, and then 3 minus 2 is 1. Hence solve, f g of x is 43. So just double checking, it's the same expression. So we're solving 6x plus 1 equals 43. 6x plus 1 equals 43. The plus 1 goes over to make it a minus 1. Divide both sides by 6. 42 divided by 6 gives you 7. And that's our solution to question 7. G of x is 2x minus 3 over x plus 4. Find an expression for the inverse. So again, we change g of x into y. Then we know to find the inverse, we are swapping the x and the y. So we get x equals 2y minus 3 over y plus 4. Then we get rid of denominators, put a bracket around this, and we're going to times both sides by y plus 4. Expand the bracket. Now remember what we're doing, we're rearranging for y. So what you want to do is you want to keep as many things positive as possible. So, you know, so many students, they move everything to the left side. But if you do that, the 4x here would go to the other side and we would have minus 4x, minus 3. And there's a lot of minuses. The better way is this xy, bring it to the right side. So it's a negative xy. Then this minus 3, bring it over here, so it becomes a plus 3. Now we factorize out the y. So we have 4x plus 3 is take out the y, 2 minus x. And then finally we divide by that bracket. I'm just going to go up here. So dividing by the coefficient of y, we would be left with y on its own now is 4x plus 3 divided by 2 minus x. So we get the inverse of g is 4x plus 3 over 2 minus x. Now, the other alternative, if you rearranged it the other way, is times top and bottom by minus 1. You could have got minus 4x minus 3 over x minus 2. So that's the other solution, but I would much prefer it if you use this as your solution instead, because we want to keep as many things positive as possible.